Hello everybody, happy Tuesday. Today is the very last day before our review and our test on Thursday. So today we are just going to be applying everything we know about signed numbers. So let's go ahead and look at the warm-up. So we have 3 problems. If you eat 5 grapes per minute for 8 minutes, how many grapes will you eat? If you hear 9 new songs per day for 3 days, how many new songs will you hear? If you run 15 laps per practice, how many practices will it take you to run 30 laps? Go ahead and take about 5 minutes to try this and then come back if you need help. Alright, so we can do all of these 2 ways. I'm going to start with a table and then we will just do a very much simpler way. So for the first one, we know the number of grapes, and we know the time in minutes. I know that we can eat 5 grapes in 1 minute because that's what per minute means. If I want to know in 8 minutes, how many grapes would I eat? Well, to go from 1 to 8, you would multiply by 8. And so to go from 5 to our number, we also need to multiply by 8, giving us 40. So, another simple way is that since it's 5 grapes per minute and I know 8 minutes, it's simply 5 times 8, giving us 40. So, we can eat 40 grapes. For problem 2, another table, we know the number of new songs and we know the amount of days. You hear 9 songs per day, and I want to know in 3 days how many you would hear. So, to go from 1 to 3, you would multiply by 3. So I'd also have to multiply 9 by 3, giving me 27. Well, again, a simpler way. I know the amount of songs per day, and I know my amount of days. So that'd be 9 times 3, giving us 27. So 27 new songs. And for this last problem, it will help us with our table. So, we run 15 laps per practice, and I know the number of laps. So, the number of laps, and we'll call it the amount of practices. So, I can run 15 laps per practice. I want to know in 30 laps, how many practices will it take? I know to go from 15 to 30, I would need to multiply by 2. And so to go from 1 to my number, I would also need to multiply by 2, giving me 2 practices. Well, another way we could do this is actually dividing. I know the number of practices, which is 30, and I know my rate, which is 15 laps per practice. So I would do 30 divided by 15, which would also give me 2. So that'd be 2 practices. All right. Okay, let's go ahead and look at our tasks for today. So we have the water level in the aquarium. So we actually have a lot of information that we're going to need to sort through and figure out what is necessary. So a large aquarium should contain 10,000 liters of water when it is filled correctly. It will overflow if it gets up to 12,000 liters. The fish will get sick if it gets down to 4,000 liters. The aquarium has an automatic system to help keep the correct water level. If the water is too low, a faucet fills it. If the water is too high, a drain opens. So a faucet fills, a drain obviously drains it, takes water out. One day, the system stops working correctly. The faucet starts to fill the aquarium at a rate of 30 liters per minute, and the drain opens at the same time, draining the water at a rate of 20 liters per minute. So let's start with these first 2 problems, and then we'll move on to this problem. So is the water level rising or falling when this happens? So is it rising with 30 liters per minute versus 20 liters per minute draining? So you're going to have to look at those and figure out if it's going to be rising or if the water level is going to be falling or if it's draining. And then how do you know? And then problem 2 asks, how long will it take until the tank starts to overflow or the fish gets sick? So again, this comes from number 1, is it rising or falling? And then how long would it take for either an overflow or to get down to that 4,000 liters where the fish gets sick? Take 5 minutes to work on these 2 problems and then come back once you're done. Okay, so is the water level rising or falling, and how do you know? Well, if we're rising at 30 liters per minute and draining at 20 liters per minute, I know that this is going to be rising because it is filling faster than it is draining. More importantly, if it's rising at 30 liters per minute, that would be a positive 30. And then at the same time, it's draining 20 liters. And since it's draining, that would be a negative number. So I could add a negative 20, which again is also the same thing as 30 minus 20. Adding a negative is the same thing as subtracting a positive. And so it's actually rising at 10 liters per minute. I know it's rising and not falling because our 10 is positive. If this ended up with a negative 10, then it would actually be draining. So how long will it take until the tank starts overflowing? Since it's rising faster than it's falling, it's going to actually end up overflowing at some point. Well, to get to the overflow point, we need an additional 2,000 liters. We need to get to 12,000 liters, and we're starting at 10. So we start at 10,000 liters and overflow is 12,000 liters, which means that we need to figure out how quickly it would take to get to the 12,000 liters or to fill 2,000 liters. So I need to know how quickly we can get to 2,000 liters using our 10 liters per minute. So again, this is going to be kind of similar to this problem up here. Well, I'm going to use division. I'm going to create a table real quick to help us. We know our we know our speed, and we know our time. So our speed is 10 liters in 1 minute. And then I want to know how quickly we would get 2,000 liters. Well, to go from 10 to 2,000, that's kind of hard. So I'm going to use something similar to what we did over here, where I'm going to take the number we're trying to get to, and I'm going to divide it by the number that we have. So I'm going to take 2,000 and divide it by 10. This is going to give me 200. And so from 10 to 2,000, you multiply by 200. And so I would multiply my 1 by 200 as well, and I would get 200. So that means it's going to take 200 minutes until it overflows. Okay, let's look here. So a different aquarium should contain 15,000 liters of water when filled correctly, and it will overflow if it gets to 17,600 liters. One day there's an accident and the tank cracks in 4 places. Water flows out of each crack at a rate of 1/2 liter per hour. An emergency pump can refill the tank at a rate of 2 liters per minute. How many minutes must the pump run to replace the water lost each hour? So here's the thing. First of all, you need to figure out how much the cracks, the 4 cracks are draining if each crack drains at 1/2 liter per hour. So that means 1 crack is draining at this speed. You need to figure out the 4 of them and compare it to the rate that it's filling at. Go ahead and take 5 minutes, try and solve this, and then come back. All right, so if there are 4 cracks, each draining at 1/2 liter per hour, then all the cracks would be draining at -2 liters per hour. Because 4 times 1/2 is going to be 2. Now, I made this a -1/2 because we're draining. We're taking water out, just like this guy was a -20. This is going to be a -1/2. So 4 times a -1/2 equals a -2. So it is draining at -2 liters per hour. So if it's refilling at a positive 2 liters per minute, then if we look, once that drains in 1 hour, if we refill it for 1 minute, it replaces the water drained in that hour. So really, we're going to have to let it run. So the pump needs to run for 1 minute per hour to replace the water lost. Okay, let's move on to our last task. So we're talking about a Challenger Deep is the deepest known point in the ocean at 35,814 feet below sea level. In 1960, Jacques Piccard and Don Walsh rode down in the Trieste and became the first people to visit the Challenger Deep. So first of all, it is 35,814 feet below sea level. That's the important information from there. And so, 2 questions. If a sea level is represented by 0 feet, explain how you can represent the depth of a submarine descending from sea level to the bottom of the Challenger Deep. Question 2. Trieste descent was a change in depth of -3 feet per second. We can use the relationship y equals -3x to model this, where y is the depth in feet and x is the time in seconds. Using this model, how much time would the Trieste take to reach the bottom? Try both of these problems for about 5 minutes and then come back if you need help. Alright, so first of all, we can explain how to represent the depth of a submarine descending from sea level with negative numbers. So the negative number is going to be anything below sea level. If you go above sea level, that would be a positive number. Trieste descent was a change in depth of -3 feet per second, and we can use the relationship y equals -3x, or -3 times x, to model this, where y is our depth in feet and x is our time in seconds. So our question is, how much time would the trice take to reach the bottom? Well, the bottom is at 35,814 feet below sea level, so that's going to be a negative. I can take our depth in feet and replace it with y. So this can actually be a negative 35,814, and that's going to equal negative 3x. And I'm trying to find x, or the time it takes to reach that point. So we're going to do a quick review. Draw the line from the equation, from the equal sign, and this is going to act as our balancing line. You cannot do something to one side without doing the same thing to the other. I want to get x by itself, so I'm going to use the inverse operation. The inverse operation of multiplying would be dividing, so I need to divide both sides by negative 3. This is going to cancel out both of the negative 3's on this side, because negative 3 divided by negative 3 is going to be 1, which would just be 1x, or x in general. And so then I'm going to take 35,814 and also divide that by negative 3. 5,814 divided by negative 3. That gives us 11,938. So it is going to take 11,938 seconds for the trice to reach the bottom. This is seconds because that is the rate that it's descending at, negative 3 feet per second. So that's a lot of seconds. If you want to change that into minutes, you would divide by 60 and you would get 198.97 minutes that it would take, or 3.32 hours it would take. But I'm just going to leave my answer as seconds. So the lesson synthesis. We can represent speed with direction, or velocity, using signed numbers, and we can do this with vertical movement. So something filling up or going down, or up and down with the Picard, it's going above or below sea level. And the convention is that up is the positive direction and down is the negative direction. So a convention is an up and down movement. So the Picard is going up and down instead of side to side. So that is what a convention is. Okay. Hopefully you can solve problems that involve negative rates and can solve problems that involve multiplying and dividing rational numbers. And if you have any questions, please get on the Google Meet. Do not forget to do your Go Formative for today. Have a wonderful day, and I will talk to y'all tomorrow.